So today we are going to be solving a Sangaku geometrical problem. These are basically very interesting geometrical problems from Japan. And also this is my first video on the channel in which I am solving a Japanese geometrical problem. If you enjoyed this video, do comment below and I will bring more of them. And also I would like to thank my friend YouTuber Cybermath because this particular geometrical problem I took from his YouTube community post. Okay, now let us talk about this geometrical problem. So it is basically saying that we have a right angle triangle ABC. In this right angle triangle, we have a square, a rectangle, and these two congruent yellow circles that are arranged in the particular pattern as you can see in this diagram. Now the question over here is to find the radius of these congruent circles when the height of this right angle triangle is equals to 3 and the base of this right angle triangle is having a length 4. So this is Anmol, and now let us see the solution. How can we find the radius of the circle? Now let us start with the solution. So the first thing that we are going to do is we are going to find the hypotenuse of this right angle triangle. So by applying the Pythagoras theorem, the length of the hypotenuse is going to be 5. Okay, this was very easy. Now the second thing we are going to do over here is that we are going to mark the angle A as a variable theta. Okay, now we can clearly see that the triangle ABC is a right angle triangle. One angle is 90, the other angle is theta. Therefore, by applying the angle sum property, the value of this third angle, that is the angle ACB, is going to be simply 90 minus theta. Okay. Now what I will do is I will take the side length of this particular square as a variable. So let that be equals to x. And also I will take the radius of these congruent circles as a variable r. So the question over here is basically to find the value of r, not x and neither theta. We have to find the value of r, that is the radius of this congruent circle. Okay, so we are going to utilize that thing later on, but just remember we have taken the radius of the circle as a variable small r. Okay, now what I can see first of all is that this particular figure is a square, so all the four sides would be equal, that is simple, and also all these four angles would have a value 90 degree. Similarly, this below figure is a rectangle, therefore all the four angles would have a value 90 degree, and also the opposite sides are equal, so we are going to utilize that thing later on. So now coming back to this square, so what we can see is that this angle is 90 degree, this line is a straight line, therefore by linear pair this angle is going to be 90 degree. Now we can see that here we have again formed a right angle triangle, 90 degree, theta, therefore by angle sum property this angle is going to be 90 minus theta. That is not needed also, just that's not needed. Forget about that. Okay, so now let us talk about similarity. So before that, let me just label some of this thing in the diagram. So let the square be labeled as PQ, this point as R. Okay, so now what I can see is that the particular triangle PQA is similar to the triangle CBA. Recall that this angle was 90 degree by linear pair. Now how these two triangles become similar to each other? Because we can see in the triangle PAQ, that is over here, in this triangle we can see that the value of the angle P is going to be 90 minus theta as we saw. Now in the triangle PQA, the value of the angle Q is 90 degree and the value of angle A is theta that we have directly considered in the beginning. Now we can see that in the triangle CBA, the value of angle C is also 90 minus theta, the value of angle B is 90 degree and the value of angle A is theta. So we can see that in this both triangles, three of the angles are equal. Hence, these two triangles are similar to each other by the property of angle, angle, angle. Now, if you remember, I told you no need to mark this as 90 minus theta. You can mark and you can use this angle, angle, angle. And if you have not marked that thing, you can even prove these two triangles are similar by angle, angle. Your wish, okay? So I'm just removing this thing from here because I need space. So now as these two triangles are similar to each other, and also we have labeled these things according to the correspondence. That is, the first angle equals to the first angle, the second one with the second, and the third one with the third one. And the fact writing these triangles according to the correspondence is used to mark the ratio of the sides as equal, and that we are going to do just now. So once two triangles are similar, the ratio of their sides become equal. Therefore, PQ upon CB would be equals to QA upon BA, and this ratio would be equals to PA upon CA. So now we can see that in this particular diagram, we have marked some of these things as variables and also some of these things are given directly as length. For example, the length of PQ we have taken as a variable x. The length of CB is ultimately the base of this biggest right angle triangle, that is having a value 4, equals to QA that we have not marked as anything, therefore QA divided by BA, that is the height of this right angle triangle, having a value 3, and this thing equals to this particular ratio, and we are not going to take that thing, that is not required. So now we have this particular equation right over there, and if I just simplify this equation in order to get the value of QA, it would be equals to 3 times x divided by 4. So here we have got the length of QA in terms of x. So in this particular diagram also we will mark the length of QA, and that we have got as 3 times x divided by 4. Now look carefully in this particular right angle triangle, the value of the base is 3 times x upon 4. The value of the height is equals to x. Therefore by Pythagoras theorem, the length of the hypotenuse, that is going to be AP, this is going to be the hypotenuse for this right angle triangle, the length of that would be equals to square root of this square plus this square, and that would be resulting in 5 times x upon 4. This is going to be the length of the line segment A. Now we will mark one more similar pairs of triangle, and for that I will take help of this rectangle. So in this we can see that first of all this angle is 90 degrees. Let me just zoom over there. So the first thing we can notice over here is that this angle is 90 degrees, therefore by linear pair this is 90. This angle we have got as 90 minus theta, therefore by angle sum property this is theta. Now this is 90, this is theta, this is a straight line, therefore the addition of this and this should be equals to 180. Two of its angle are already having a value, therefore this would finally turn out to be 90 minus theta by simplification. Now look carefully over there. We can see that this angle is 90 degree. By linear pair this angle is 90 degree. This angle we have already got as 90 minus theta. Therefore for this particular triangle, that is a right angle triangle, one of its angle is 90 minus theta, the other is 90. Therefore the value of this third angle is going to be theta. So what we can see that is we again have a right angle triangle, means already a 90 degree, and one more angle equals to theta, and we have already seen that the biggest triangle ABC is also a right angle triangle at B and having one of its angle as theta. So as in these two triangles, two of the angles are equal, they are again going to be similar. So let us write down the thing according to the correspondence. So before that we have to label this diagram. So this point is already R. Let this point be S and this particular point over there be equals to T. So we can see that the triangle SRT is going to be similar to the triangle. Angle S is equals to theta, and in the triangle ABC angle A is theta. The second we have written is R. So the value of angle R is 90. For the triangle ABC the 90 degree is B. Therefore the final thing is going to be C. So these two triangles are similar to each other by angle, that is two of the angle in these two triangles are equal. Now as we have written this thing according to this correspondence, the ratio of their sides would be equal and there would be no difficulty in writing that thing. Therefore SR upon AB, the pair of this and this, equals to the ratio of RT upon BC. So RT upon BC, and this thing would be equals to ST upon AC. So ST upon AC. Now let us write down the length of this line segments. So the first thing we can see is that the length of SR is ultimately this side of this square, and that is already having a value x, divided by AB. AB is the height of this triangle ABC. Let me just make this thing smaller. So now you can see that the length AB is the height of this triangle having a value 3. This thing would be equals to RT upon BC. RT is this particular side of this triangle, so RT divided by BC, that is the base of this right angle triangle having a value 4, and this thing would be equals to ST upon AC. ST is the hypotenuse for this right angle triangle and AC is the hypotenuse for the right angle triangle ABC, and that is having a value 5. Okay. So now we have these three ratios equal to each other, and in this only one important variable is present, that is x. So what I will do is I will compare these two equations, and by doing so we will get the value of RT, and that would be equals to 4 times x upon 3. Now I will compare the first equation with the last one, and by comparing this thing we will get the value of ST as equals to 5 times x upon 3. Now recall that the length RT is this side of the right angle triangle SRT, and the length ST is the hypotenuse, and this side is already the side of the square having a value x. So basically what we did is we form a right angle triangle like this way, SRT. Here is the point S, Here is the point R, here is the point T, here is the 90 degree. This is already the side of the square, hence it was having a value x, and we have just found the value of RT as equals to 4 times x upon 3 and the length of ST, and that is 5 times x upon 3. Now we can clearly see that according to this diagram, the circle is in this right angle triangle, and it was already given that the circle is tangent to this and this line segment. Hence, the circle is the incircle for this right angle triangle SRT. So in this right angle triangle, I can easily draw that particular circle. Okay. Now we can see that we have a circle that is the incircle for a right angle triangle. And there's a very nice formula related to this thing. Let me just show you very quick. If there is a right angle triangle whose sides are A, B, C, that is the two sides A, B, and the hypotenuse is having a value C, then the radius of the incircle would be equals to A plus B minus C upon 2. So the same formula can be utilized over here. As we can see, we have a circle that is the incircle for a right angle triangle, and in the beginning we have already taken its radius as a variable R. Therefore, according to the formula that we just saw, the value of R would be equals to addition of the sides of this right angle triangle, that is going to be x plus 4x plus 3 minus the length of the hypotenuse, that is 5x plus 3, and upon 2. So the numerator can be simplified. 4x upon 3 minus 5x upon 3 is negative x upon 3. X minus x upon 3 is going to be 2x upon 3. 2x upon 3 upon 2 is simply going to be x upon 3. So here we have got the radius of the circle in terms of the variable x. That means in the whole question we were having three important variables, theta, r, and x. This was the angle, just forget about it. These were the variables that were determining the length of the important sides, and just now we have got a relation between them. That is, the radius of the circle is equals to 1/3 the side length of the square. This is the radius of the circle and this is the side length of the square. Okay. Now let us utilize this thing further, and for that, now I will utilize the fact that we have a circle over here also. So now what I will do is, first of all, I'll just remove this thing from here, the point P, the length 3, and some of the things from here. Okay. Now what I will do is I will take this particular circle over here and draw the radius to these 3 tangent points. Okay, the angle over there would be 90 degree. The 3 lengths would be equal, and that would be equals to the radius of the circle, that is R, R, R. Here is the 90 degree because it is the corner of the right angle triangle ABC. This is 90 degree by angle sum property. This particular quadrilateral is a square because all the 4 angles are 90 degree, adjacent sides are equal. Therefore, this much length R, this much length R. Now what I can see is that the complete length from A to B was 3. This much length we have got as 5x upon 4. This much length we have got as R. So if I just subtract 3 minus the length of AB minus this particular length, that is R, what I will get is the length from this particular point to this perpendicular point, that is the tangent point. Okay, and that is what I need. So I'll try to subtract these things that we have just written. So 3 minus AP minus R, the value of AP is already been found, that is 5 times x divided by 4 minus R, and the value of R we have just got as x upon 3. So let us simplify this thing. So it would be equals to 4 into 3, 12, 12 into 3 is 36, 36 minus 15 minus 4, that is going to be 19 times x, and this whole thing divided by 12. So this is the value for this particular line segment that I am just going to mark it very clearly over here. So this is the length from M to N. Okay. Now what I will do is I will simply draw a dotted line connecting the points M and the center of this particular circle. So now what I can say is that this right angle triangle and this right angle triangle are congruent to each other because right angle, common hypotenuse, these two sides equal. Hence, by the property of right angle hypotenuse side, these two triangles are congruent. Now recall that here we were having this particular right angle triangle. In this we can see that one of the angle is theta, the other is 90 degree. Therefore, by angle sum property, this would be 90 minus theta. Here we have 90 degree because it is a corner of the square. This is a straight line. We have 3 angles dividing it. This angle is 90 minus theta. This angle is 90. Therefore, by simple simplifications, you can get the value of this third angle, that is the complete angle over here, as, let me just clear it, the complete angle over here, and that would be equals to theta. Now as we can see, these two triangles are congruent, therefore these two angles in these both triangles would have the same value. The combined value of that two equal angle is equals to theta, therefore each of them will simply become theta upon 2 and theta upon 2. Now we can see that here we have this right angle triangle, so let me just redraw this right angle triangle outside. So the right angle triangle is like this way, okay? Here is the angle theta upon 2, here is the 90 degree, this length is the radius of the circle and that is having a value x upon 3. This is the line segment MN and we have already got its value as 36 minus 19 times x divided by 12. And simultaneously take the biggest right angle triangle ABC, that is like this way, ABC, here is the 90 degree and this angle is having a value theta, the height is 3, the base is 4 and the hypotenuse is 5. So till now we used the concept of similarity, now we are going to use trigonometry. So look carefully in this right angle triangle. From this right angle triangle, the value of tangent of theta would be equals to 4 upon 3. Now we all know this particular rule that tangent of capital A plus B would be equals to tangent of A plus tangent of B divided by 1 minus tangent of A tangent of B, that is the product of these both terms. So this is the identity. Now in this particular identity, if I simply replace A as theta upon 2 and B also as theta upon 2, the identity will look like tangent of theta is equals to 2 times tangent of theta upon 2 divided by 1 minus tangent square theta upon 2. Okay, so we have this particular relation between the tangent of theta and tangent of theta upon 2. Now we already have the value of tangent of theta, that is going to be 4 upon 3. So I'll put that value over here. So let me just change the color. So the value of tangent of theta is going to be 4 upon 3 equals to, for now I will just take tangent of theta upon 2 as equals to t. So 2 times t divided by 1 minus t square. So now I can see that from the table of 2 this thing will go out as 2. By doing the cross multiplication and adjustment of the terms, the thing will look like 2 times t square plus 3 times t minus 2 equals to 0. The quadratic equation of this thing will form like 2t square plus 4 times t minus 2 equals to 0. The factors of this thing would be t plus 2 multiplied by 2 times t minus 1, this thing equals to 0. From this thing we will have two values of t, that is going to be 1 upon 2 from this bracket or else negative 2 from this particular bracket. Now recall that we have taken t as tangent of theta upon 2 and according to this diagram the value theta upon 2 is a positive angle and that is also acute. So we all know that tangent of an acute angle and lying in the first one means a positive angle would always give a positive result, hence we cannot take negative 2 value. So here we have got the value of tangent of theta upon 2 and that is 1 upon 2. So I will write it this thing at the top. So we have got the value of tangent of theta upon 2 as equals to 1 upon 2 and this thing would be equals to x upon 3 upon 36 minus 19 times x upon 12. This thing came as the value of tangent of theta upon 2 using this right angle triangle. Tangent of theta upon 2 perpendicular upon the base, hence x upon 3 upon 36 minus 19x upon 12. Okay, so now let us simplify this thing. So 1 upon 2 would be equals to 4 times x upon 36 minus 19 times x. This thing would be equals to 36 minus 19 times x equals to 8 times x. Solving this thing, so x would be equals to 36 upon 27 and this thing would be equals to 12 upon 9. Let us simplify that thing also further. So it would, so finally from the table of 9 this thing will go out as 4 upon 3 and this is the value of x. But this is not the answer because x is the side length of the square and what we are looking is the radius of the circle. So the radius of this circle we have taken as a variable r and we have seen a relation that r is equals to x upon 3. The value of x we have just got and that is 4 upon 3. Putting that value over here will give me the value of r and that would be equals to 4 upon 3 into 3, 9. And this is the answer that we were looking for. Now there's one thing to be noted in this diagram and that is this rectangle. The thing is that there is no requirement of this particular figure to be a rectangle, at least in my solution. Let me show you. We utilize this angle as 90 degree for over here, okay. This angle as 90 degree over here, okay. this point is intersecting and that we have utilized to form this right angle triangle. Okay, but this leg is perpendicular, we have not utilized this thing. It can even go like this way, or even like this, or even like this. Any way it can go, and still it will make no change in the solution. You just think, if I just remove this perpendicular from here and draw another line segment in place of this thing, and that will be just like this way. So we can see that this become an acute angle, this become an obtuse angle, hence this become a trapezium, not a rectangle. And still the solution would be same. Nothing changed. This angle would still be theta because we have got this thing from here and this angle is 90. Yes, we need these two angles as 90, but not these two angles as 90. Only three things were required in this. These two angles 90 degree and this point contacting the square. Okay, because that forms a triangle. So that is why I was telling that this bottom figure, in this only these two angles should be 90 degree and this point touching the square, and there's no necessity that this should be a rectangle. So this was my way to solve this particular problem. If you have any other method other than this, and especially if you have utilized the fact that this figure is a complete rectangle, and even if my solution is wrong, or this fact that it has to be necessary a rectangle, the fact I told that yes, it should not necessarily be a rectangle, if this fact is wrong, do let me know in the comments. I would be glad to hear what is my mistake, or be very happy if I figure out this thing. So if you have any other method, do comment. And if it's hard to comment, or if you have to share any kind of photo, you can email me, or else you can send it to me on my Instagram. The link is in the description.